we want to calculate the resistance of this resistor given the color coding that we have here. Now, this is somewhat exaggerated, but let's look at another image. This is an image of the color code of a resistor. Here we have the 4-band and the 5-band resistors. Now notice the first color you start with is the one that is nearer to the end of the resistor. One that is nearer to the end, and you have these 3 colors close to it. Then the 4th one, at the 5-band, you have 4 colors that are close together starting at the end, and then some distance away from them is the 5th color. All right, so how close the bands are, the stripes are, tells you which colors you should use for what part of the calculation. Now, here you will have the last color here as a tolerance. The tolerance can be plus or minus 5%. It can be plus or minus 10%. Here, when you look at a group of resistors, you have the first resistor, first digit, so digit 1, second resistor, digit 2, third resistor, third stripe, third color, I should say. So we have the first color is digit 1, the first digit. Second color is the second digit. Third color is the third digit. The 4th color is a multiplier. It tells you times 10 to the what power, right? 10 to the x. So here, that's the 5-band resistor. Let's look back at our image. 5-band resistor. Now you have first color, first digit, second color, second digit, third color, third digit, then the multiplier, then the tolerance. For the 4-band resistor, first color, first digit, second color, second digit, then the multiplier and resistance. It's always digit, 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 then multiplier, then resistance. Digit, 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 multiplier, resistance. That's the pattern. Alright? So the color that's far from the group of 4 or 3 colors is the tolerance. Then you go to the left is multiplier, and everything else to the left of that are digits. Now, let's see what that means. We want to calculate the resistance of this resistor. The first digit is green. Now, what's the first color is green. What's the digit that represents green? Let's see. Green, that's 5. So for green, that is 5. Then the second digit, the second color is red. What digit represents red? Let's see. That's from the table, that's 2. So you'll find these resistor color code tables in various places on the internet and in books. Alright? They're all the same, universally. So we have red, which is represented by 2. When I say digit, I'm speaking of what this table calls value. Alright? So that's 2. That's 52. Since it's a 5-band multiplier, we still haven't used, since it's a 5-band resistor, we still haven't reached the color where we use multiplier. We've covered 2 so far. So the third one is going to be the third value or digit. It is yellow. Let's look at the table for yellow. Yellow represents 4. 4. So it's 524. Now the multiplier means you multiply by 10 raised to a certain power. What is the power? This is blue. So the fourth color is blue. Where is blue now? Blue, the multiplier here, is 6. It's 10 to the 6. Some tables might not have the multiplier column here, but it's always 10 to the power of the value. When the value is 0, it's 10 to the 0, value is 1, is 10 to the 1, value is 2, is 10 to the 2. Alright? So, in this case, for blue, the value is 6. So the multiplier is times 10 to the 6. So it's times 10 to the 6th. Then the tolerance. Or what variation from the exact value are you going to tolerate? There's going to be plus and minus. This is gold. So let's look for the tolerance for gold. Gold is plus or minus 5%. Alright. Plus or minus 5%. So let's work it out. This is going to be 524 times 10 to the 6 means 6 zeros. Plus or minus 5%. Now this is a very big number, 524 million. What we can do is call it 524 mega ohms, right? But let's work with it for now as it is. Now, plus or minus 5% means you have a range of values within which the resistance will lie. And the highest value it should be 524 million plus 5% of that. Now, that will be 524 million plus 5 divided by 100 times 524 million. Now what is that? Let's get our calculator. Alright, so we have our calculator here. So 5 divided by 100 is 0.05 times 524 million equals. Alright. So we have 26.2 million plus 524, 1, 2, 3, 4, 5, 6 zeros. Alright, so what that gives us is 550, 200,000. So that's equal to 550, 200,000. which is 550.2 mega ohm. So you see that. Now, what is the lowest value that it should take? That's going to be 524 million minus 5%, which is 524 million minus 5 divided by 100 times 524 million. So let's get our calculator again and get that figure. So we have 5 divided by 100 equal 0.05 multiplied by 524 million ohms. Okay, good. Now we're going to, instead of adding, we're subtracting. 524 million ohms minus that gives us, and we get 497,800,000. So the lowest value is 497,800,000. Let me put the ohm sign. So it is 497,800,000 ohms, which can be written as 497.8 mega ohm. So the value of the resistor, the resistance, is equal to 497.8 mega ohm to 550.2 mega ohm. The range of that resistor is somewhere between 497.8 mega ohm and 550.2 mega ohm.